All right, this is another type of a trickier situation here. We are looking at dealing with the same distance going back and forth between two places, but we're talking about a boat going up and downstream. So this is a trickier situation here. So we do have to remember that when we're dealing with distance, we do have a simple, nice equation of distance. So distance is equal to your rate that you're going at times the time that you take to get there. So we have two things happening here. We have, when you're dealing with a boat going in anything, if you're talking about boats or planes, you're talking about like wind resistance or currents in this situation, we have to deal with what is happening here. So we do have two different types of equations here that we are focusing on. And what I'm going to do is I'm going to draw a quick little sketch so you can kind of see what this looks like. So we're going to do rate times the time, and we have our distance, which if we're looking at this, distance is going to be the same, right? Because I'm going to one place and then I'm coming back. So the distance is going to be the same, which if you look at this problem, it's 24 miles. So our total distance is going to be 24 miles one way, 24 miles the other way. So we're going to talk about going downstream first and then what happens with upstream. So when we're going downstream, it takes us 2 hours. So our time for this is going to be 2. And then we're told the return trip, so coming upstream, it's going to be twice as long. So 2 times 2 would be 4. So that's how long it's going to take me hours-wise. Now, when I'm dealing with speeds of boats in still water versus currents, this is where we have some problems. So I am going to call X the still water, and that's the speed that we're going to be traveling in, speed for that. And then we have the speed of the current as the other thing, so our Y. So when we are looking at, current, these, we're opposing forces. One of them is going with the current, the other one is coming against it. So when we're looking at the rate that we're going at, we have opposite directions. Again, you're dealing with opposite forces here. You're talking about still water versus the speed of the current going upstream is going to be opposing. So opposing, you're doing different directions. This is going to be X plus Y. So you're going with it. So you're going to go faster downstream because you're going with the current versus when you're going against it. So this one is going to be X minus Y. So again, this type of a question happens with planes, talking about winds, and when you have wind coming against you, that also happens as well. So we're going to take a look. We're going to do this times this, which is going to equal this. So the first one, 2 times the X plus Y, which equals 24. Again, you're just doing this column times this column equals that. The other one is going to be 4 is the time, times the X minus Y equals 24. So now all I'm going to do is distribute that out. So 2x plus 2y is going to equal 24. And then on this one, 4x minus 4y is going to equal also 24. Now, what I want to do is I'm going to use elimination in this problem. I'm going to try to eliminate this. Let's go with the y's because the y's are already opposites. So if I just multiply this top one by 2, I'll have an opposite opposing situation here. So 2 times 2x is 4x. 2 times the 2y is going to be plus 4y. There's your opposite pair right there. 2 times 24 is 48. So now we're going to combine these two right here. 4 plus 4 is 8x. These cancel. And then we've got 48 and 24, which is going to be 72. Divide both sides by 8. Your x is going to equal 9. So that is going to be 9, and we're talking about miles per hour here. So your still water speed is 9 miles per hour. And then we can go back over here and solve for the other one. So again, it doesn't really matter which one you choose. So if I look at, I'm just going to go here. If I plug in x here with 9, we've got 2, and then you have 9 plus something equals 24. 2 times 9 is 18, plus 2y equals 24, minus 18 on both sides. That leaves me with 2y equals 6. Divide both sides by 2, and you get y is equal to 3 miles per hour for this problem. So when it asks me what is the speed of the boat in the still water, I'm really only worrying about the still water speed, which in this case would be 9 miles per hour. If you want more questions like this, you can find them in my YouTube channel, You Want Algebra. Check them out under Systems of Equations.